Sunlight just outside Earth's atmosphere has an intensity of 1.40 kilowatt per meter square. Calculate E0 and V0 for sunlight there, assuming it to be a plane wave. So we have the equation for the intensity as the intensity here given. The intensity I is equal to 1.40 kilowatt per meter square into 10 raised to 3 watt per meter square. But the intensity I is equal to half C epsilon 0 E0 square. Therefore, E0, the value of E0 is E0 square is 2I by C epsilon 0. Then substituting this value gives 2 into 1.40 into 10 raised to 3 divided by 3 into 10 raised to 8 into epsilon 0 8.85 into 10 raised to minus 12. And this value it will give. Therefore, E is equal to 1.026 kilovolt per meter. This is the value of E0. This is the value of E0. And similarly, B0 can be found out. That is the expression for the intensity in terms of this magnetic field. That is, in this equation also, intensity I is equal to C epsilon 0 E0 square. But E and B are related. E0 by B0 is equal to C. Therefore, instead of E0 square is equal to C square B0 square. But C, we know that C is equal to 1 by root of mu 0 epsilon 0. Substituting these values into this equation, that is I is equal to half C epsilon 0 E0 square instead of C square B square. Then B0 square, instead of this C square, we can write it as 1 by C is 1 by root of mu 0, C square is 1 by mu 0 epsilon 0. This mu 0 and mu 0 will cancel and it will give 1 by 2 mu 0 C B0 square. 1 by 2 mu 0 C B0 square. So substituting this value, we will get B0, that is intensity is equal to 1 by 2 mu 0 C B0 square. Therefore, B0 square is equal to 2I mu 0 divided by C. So substituting the values, 2 into I is 1.4 into 10 raised to 3 into mu 0 4 pi into 10 raised to minus 7 divided by 3 into 10 raised to 8. Finally, we get B0 as B0 is 3.43 microtesla into 10 raised to minus 6 Tesla. This is the value of B0 and V0. And the next problem is, what is the intensity of a traveling electromagnetic wave if B0 is 1 into 10 raised to minus 4 Tesla. Here also B0 is given. What is the intensity of a traveling plane electromagnetic wave if B0 is 1 into 10 raised to minus 4 Tesla. This is B0. The intensity is given using this equation. I is equal to half C epsilon 0 E0 square. Like in the previous case problem, we can change this E0 to B0 because E0 by V0 is equal to C. So then the intensity can be represented as, and C can be also written as C is equal to 1 by root of mu 0 epsilon 0. Then the intensity will be 1 by 2 mu 0 C B0 square. 1 by 2 mu 0 C B0 square. Substituting the values of B0, we get C is equal to 3 into 10 raised to 8 into B0 is 1 into 10 raised to minus 4 divided by 2 into mu 0 4 pi into 10 raised to minus 7. Then we get it as the final value will be the intensity is equal to, it is about 1.2 megawatt per meter square. 1.2 into 10 raised to 6 watt per meter square. And the next problem is determine the value of Poynting vector at the surface of the sun if the power radiated by sun is 3.8 into 10 raised to 26 watt while its radius is 7 into 10 raised to 8. Say direct substitution this problem. So we know that the Poynting vector S is the power radiated per unit area or the energy per unit area per unit time. So here the power is given is equal to 3.8 into 10 raised to 26 watt and radius is 7 into 10 raised to 8 meter per second. Here the sun we are considering it as a spherical one, then the surface area will be the 4 pi r square. Then the Poynting vector S can be represented as P by 4 pi r square. P by 4 pi r square. Here the power is given 3.8 into 10 raised to 26 divided by 4 into 3.14 into r is given 7 into 10 raised to 8 the whole square. Then this will give the value as 617 into 10 raised to 5 watt per meter square.